Welcome back to my second video about Hello Moon, the online life simulation game. Today we will discuss the global architecture. I know this is quite a vague title, but I will try to cover the most essential parts of our architecture and introduce some tools and technology we will use. Now first of all, we will have a front end communicating with the back end. Yeah, I know, this might sound really obvious. But there might be multiple frontends in the future. We will start with a web application, but maybe an iPhone or Android app will follow. More important is that we will make the backend available from day one to any third party. This means everybody will be able to write custom software or extend the game experience. Think about people creating reports for their businesses, or building a voting app, allowing all players to vote. This might raise questions like, isn't it easy to cheat, and why should we build those features as a third-party application instead of creating a pull request and make it part of our global game? To be honest, I'm not afraid of cheaters building bots that abuse the backend. We can automate stuff in our life, so why not in a live simulation? It probably gives you an advantage, but other players can do the same. And it's not a goal to keep people online for as long as possible. So if automating something in the game gives you a major advantage, we should consider adding it to the game itself. Legalizing add-ons even gives us more control, because we have a better understanding of what people are doing. Creativity shouldn't be punished. Bringing us to the second question, why don't we just add everything as a feature to the game when people open a pull request? Well, even if this is an open source project and everyone is allowed to contribute, it doesn't mean I want to manage all that code and be responsible for it. Especially if a feature is only useful for a few players, it doesn't make sense to maintain this in our main repository. As I said, the frontend will communicate with the backend, but this backend won't be a monolith. It will be separated into microservices hosting their own APIs. I'll be honest with you, while recording this video, I have no clue what exact microservices we will develop, so I just added several microservices to this diagram to give you an idea. Those microservices can also consume each other, but we will cross that bridge when we get there. In the previous video, I mentioned several features I'd like to develop, and each of them will probably result in one or more microservices. For instance, the sport career feature will probably introduce a lot of services like managing teams, training schedules, etc. It shouldn't be a surprise if we end up with 100 or more microservices. To be able to fix things like SSL and not having to expose all kind of port numbers, we will place a gateway in front of all those microservices. This allows us to have a single URL protected with SSL, which hides all the microservices. Apart from that, a gateway can provide a lot of other features like load balancing and so forth, but we will look into that if we need it. Fine, so I hope this gives you an idea about our global architecture. As said, I tried to cover the essential part, so don't blame me for not going into details and bore you with huge drawings showing in-depth details of all the microservices. This is an agile project, and during the project the architecture will get clearer and clearer. Now let's take a look at the technology we will use. Since I have most experience in .NET, it makes most sense to start with that. It's not that I think other programming languages won't do the job, but I know .NET will, and I don't see advantages of other languages that would help us. To be more precise, I will use .NET Core, because it will allow us to run the server not only on Windows, but also on Linux. Because we are using microservices, it is possible to switch to other languages than C# for any particular service if needed. But of course, having all software written in the same language is a lot easier to maintain, build and deploy. So, if there's no good reason, we won't switch. The front end will have nothing to do with .NET or C#. Don't be afraid, We won't build any Razor pages or so. Or maybe you are disappointed now, but in that case please subscribe to the channel and follow this project, because in a few weeks you will be happy to learn React. I had a lot of doubts whether it should be React, Angular, Vue or any other language. I do have more experience with Angular than with React, but I really started to like React for its performance and flexibility. I think these are really important when building a game, since the difficulties we run into are different than the ones you will have building a line of business application. Some people might think you cannot use React without Redux, and even though that's not true, we will use React, yes. But keep in mind, it is a decision and not a given. We could build this without Redux, but since we do have a lot of state to handle with, it will be of really good use. The thing I really liked about Angular is that you can build your application in TypeScript. Or to be precise, you must use TypeScript. React is more JavaScript oriented. And even though I appreciate the JavaScript syntax in React, I do like TypeScript more, since the autocomplete features are way better and it gives you immediate feedback when compiling. Now I saw it is possible to use React in TypeScript, so let's give that a try. To finish the front end we will use of course HTML5, which all modern web applications do, and we'll use Sass for styling. The communication between frontend and backend will be done with REST APIs and gRPC. I'm not sure if gRPC only might be even good enough for us, but REST APIs are so commonly used and it is a perfect way to avoid the complexity of gRPC. gRPC will be a first timer for me, so don't blame me for calling it complex. I know it's probably a lot easier than I expect. Please leave a comment if you have any thoughts about mixing those technologies. After discussing this super global architecture and looking into the languages and technology, I will shortly introduce the tools I would like to use for this project. Building a .NET application begs for using Visual Studio. Even though you can use other IDEs, Visual Studio still is the most brilliant tool out there in my opinion. To build the front end, however, I think Visual Studio Code is better at the moment. It has a lot of plugins available and boots a lot faster than Visual Studio itself. Hello Moon will be an open source game, and the #1 platform to share your code is GitHub. It recently lowered its pricing and is adding new features faster and faster. I can already see the comments about using GitLab, and yes, I know GitLab is also a perfect piece of software. I even used it for a while, but the user experience of GitHub and its community is way better in my opinion, at the moment. That said, I also mentioned GitHub Desktop on this page. It doesn't really matter what Git tool you use, but this is one of my favorites. It doesn't support all the fancy features Git has, but the main features are so easy to use. To deploy your software with ease, we use Docker. If you don't know Docker, consider it a virtual machine based on an image running one piece of software. So you basically get the image of an OS, append the latest version of your software to it, and make sure it starts this piece of software automatically. Now we will not only use Docker to deploy the software, but also to build it. Since Docker allows you to script the build agent instance, it makes sure you always have the same build environment. This really improves the collaboration between team members and makes the build process easier to debug. No more "it works on my machine." Oh, I said we will use Docker for deployment, but I actually mean we will use Kubernetes. Also a first timer for me. But I've read some things about it and I think we can handle. The reason to use Kubernetes is that it's so easy to scale. Imagine having 100 microservices all having their own data stored in separate containers along with the millions of players we are targeting. We need to be able to scale fast. Talking about testing and deployment, let's take a look at the next tool, Travis CI. There are a lot of CI tools out there. While I'm working with TeamCity on a daily basis and GitHub Actions seems really interesting, I did pick Travis CI. Especially for open source projects, their offer is outstanding. You can have an unlimited amount of builds and 5 concurrent jobs. They do have a flawless integration with GitHub and support Docker. The last tool I'd like to discuss is Yarn. Yarn is a package manager we use to manage the front-end packages. If you know NPM, Yarn is an improved version of NPM. From what I've read, it can be a lot faster, so that's the reason we should give it a try. For another project I already migrated from NPM to Yarn, which didn't give me the performance increase I expected, but even the smallest performance gain is important for us. Thanks for watching this video. Your support is really important to me. Please hit the thumbs up button and subscribe to the channel to keep updated about all development on Hello Moon. Next time we will start setting up our GitHub environment.